So chapter 4 is all about exponents, polynomials, and polynomial functions. In section 4.1, we're going to have an introduction to integer exponents and scientific notation. So an exponent is a whole number that indicates how many times a base number is to be used as a factor, i.e. multiplied by itself. So let's look at this example down here. I have 8 to the third power 8 cubed. That means I want to take 8 times itself 3 times, which is 8 times 8 times 8. I like to think that exponents were invented because mathematicians are lazy, right? It's a shorthand for repeated multiplication. And yeah, writing 8 times itself 3 times isn't so bad. But what if I had 2 to the 12th? Or 10 to the 108th? A, those are really, really big numbers. And B, that'd be really frustrating to have to write over and over again. So that's how this exponential notation came about. The formal definition is if n is any positive integer and a is any real number, then, sorry for the typo, then the nth power of a is written using exponential notation as follows. A to the n equals a times a times a dot 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 for n factors of a. So if you have something raised to the second power, typically you say 9 squared. That comes from the equation for the area of a square, which is its side times itself, so side squared. Same thing with cubed. If I was to calculate the volume of a cube, oh, actually that's a pretty good looking cube. That would be side cubed, because I would take each of the lengths of the sides times itself. We have 5 to the first power, 3 to the fourth power, n to the 0 power. Anything above 3 or below 2 doesn't have a special name like squared or cubed. It's important to note that any number other than 0 raised to the power of 0 is 1. So 7 to the 0 power is 1. 10 to the 0 power is 1. It's important to note that 0 to the 0 power is undefined. So if I have 6 to the 0 power, let's switch to a nicer color for this background, that's going to be 1. If I have 5 to the 0 power plus 12 to the 0 power, we're going to simplify, take care of the exponents. That gives me 1 plus 1, which is 2. And if I have 8k to the 0 power, we're going to distribute that. So I'd have 8 to the 0 times k to the 0, which is 1 times 1, which is 1. So any number other than 0 raised to the 0 power is 1. The first rule I want us to take a look at is the product rule. If a is any real number and r and s are integers, then a to the r times a to the s is a to the r plus s. So basically what we're saying is to multiply exponents with the same base, we add exponents and use the common base. Why does this work? Well, let's say I had 2 squared times 2 cubed. That's 2 times 2, right, 2 squared, times 2 to cube, which is 2 times 2 times 2. We could rewrite this as 2 times itself 5 times. Well, 5 is 2 plus 3. That's why this rule works. So if I have 5 cubed plus 5 to the first, that gives me 5 to the 3 plus 1, which is 5 to the fourth. If I have x to the 8th times x to the 7th, that's x to the 8 plus 7. That is not my neatest handwriting. Let's try that again. X to the 8 plus 7, which would give me x to the 15th. If I have 3 to the 4th times 3 cubed times 3, remember that any number all by itself is the same as raising it to the power of 1. So I'd have 3 to the 4 plus 3 plus 1, which would be 3 to the 8th power. And in this case, what we would do is we would multiply, right? We distribute. So I've got negative 8y cubed times y to the 4th. That would give me negative 8y to the 3 plus 4, which is negative 8y to the 7th. The next rule we need to talk about is the negative exponent rule. If r is a positive integer, then a to the negative r is 1 over a to the r, and you can pull out that factor of r if you want. i.e., negative exponents are fractions. 4 to the negative 3 is 1 over 4 cubed. 3x to the negative 3 is 1 over 3x cubed, right? We could then distribute that if we wanted. Simplify if we wanted, but we don't have to. If I have 3x to the negative 3, it's important to note that that negative 3 is only attached to the x. So I'd have 3 times 1 over x cubed, which would give me 3 over x cubed. Now, if I have a negative exponent, I already said that those are fractions, so if I have it in the denominator, what happens? So I have 1 divided by 1 over 4 cubed. This is what we call a complex fraction. We don't like these, so let's go ahead and divide. I have 1 divided by, so that's what this bar means, divide. 1 divided by 1 over 4 cubed. When I divide fractions, I keep the first fraction the same, change from division to multiplication, and flip the second fraction. So I'm left with 4 cubed. 4 cubed. Let me make that look a little bit more like an exponent. So the key takeaway should be that if I have, why did we change colors? If I have a negative exponent in my denominator, it moves to my numerator. And you can hold that as a fact. That way you don't have to do fraction division every time.